All right, today we are going to talk about lesson 3.4. If you're worried about lesson 3.3, don't be. We're skipping over it, okay? I told you multiple times we don't do proofs in geometry anymore, so we're not doing that. Okay, so this lesson is about finding and using slopes of lines, okay? So if we look at my first graph here, I have 2 points here. First, let's just notate what those ordered pairs are. This point here is 1, 3. And then that second point is 4, 5, I believe. The numbers are really tiny to see. Okay, and then here is the slope formula. Remember, it's the vertical change over the horizontal run, rise over run. If I attempt to connect these lines, it's not terrible. If you're given a graph, you can count how many units up. So we count from one point. We're going to count how many units up and then how many units over to get to that point. Remember, slope is usually in a fraction. So if I count units up, I have 1, 2. So my vertical change is 2. Let me just change. So this is a 2. And then 1, 2, 3 over. So I should get 2 over 3. But let's use the slope formula. So first, this is my x1, my y1, x2, y2. All right, so now we just plug it into our fancy formula. 5 minus 3 over 4 minus 1. 5 minus 3 is 2. 4 minus 1 is 3. Hey, we got 2 over 3. All right, all right. It's a beautiful slope. It's nice. Okay, so you can use the graph or you can use the formula if you're not given the graph. I would recommend knowing how to do it both ways. All right, let's look at example number 2. All right, I have 1 point here that would be -2. So -2, 4. Oh boy, my pen is working. And then my second point up here is -3, -3, 7. All right, we're going to plug into our fancy formula. Remember, it's y2 minus y1, so 7 minus 4 over x2, which is -3, minus x1 minus a negative. Remember what happens with minus a negative? It becomes addition. That's my sound effect for today. All right, all right. 7 minus 4, that's easy peasy. It's 3. -3 plus 2 is -1. All right, this reduces to a slope of -3. Because 3 divided by -1 is -3. All right, now let me attempt to draw my fancy line through the points. It didn't really make it, but I think we can get the gist. We can also count the vertical rise over the run. So it's 1, 2, 3. So that's a +3. But then when we run to the left, remember the coordinate plane is made of 2 number lines. Up is positive, down is negative. Right is positive, left is negative. We have to move to the left. So that gives me a -1. So that'd be 3 over -1, which is -3. Again, I apologize for my handwriting, but you should be able to use both methods to determine the slope of a line. All right, now what happens when I give you more points here, okay? So what we're going to do is we're going to draw 2 lines through those points. Hopefully I can do a good job here. Yeah, pretty good. Okay, and then let me change the colors and I'll draw a line through these points here. Ooh, that one actually, I mean, if I do say so myself, I did a pretty nice job. All right, so first let us find the slope of the purple line. We're going to use the 2 ordered pairs here. I have -2, 0. And my second ordered pair is -5, -5, 3. And in hindsight, I should have made this graph a little bigger for myself because it's very tiny for me to see these numbers. I'm going to plug these into the slope formula. I'll remind you what that is over here. Remember, that is the change in y, so y2 minus y1 over x2 minus x1. Let's plug and chug, as they say. So 3 minus 0 over negative 5 minus negative 2. Remember, minus a negative is a positive. The most important thing I want to point out is that these numbers, top and bottom, come from the same ordered pair, 3, negative 5. Okay? That's super important. Don't take one, start with one ordered pair and then in the denominator start with the other one, because it'll mess you up and you'll have the wrong slope, and that won't be good. 3 minus 0 is 3. I almost said 0. Negative 5 plus 2 is negative 3. And 3 over negative 3 is negative 1. Let's take a look at the pink line. Okay? I have this lower point here that is 1, 2, 3, 4, 5, 5 comma 1. And then my point all the way up here is 1, 2, 3, 4, negative 4. And then I believe that's 10. 3, 4, 5, 6, 7, 8, 9, 10. Yes, it is. All right, let's chug away. Right, 10 minus 1 over negative 4 minus 5. 10 minus 1 is 9. Negative 4 minus 5 is negative 9. 9 over negative 9 is negative 1. Okay, these lines have the same slope. That makes them parallel. So we can go ahead and put our little triangles on it. I know, like, looking at it, it doesn't really look like 100% parallel, but the proof's in the pudding, okay? Same slope means parallel lines. All right, and the notation for parallel lines looks like an 11, but it's like that. Okay, that means parallel. Wonderful, wonderful, wonderful. Let's take a look at number 4. Here we have an example with 3 points. Well, what am I supposed to do with that? Well, I'm going to show you what you're going to do with that. First, we're going to make a horizontal line here. Let's change it up. We'll use red and blue. Boom. That's one line. Okay, beautiful. Now I'm going to make a vertical line. Kabooshki. I mean, it's not the worst. Not the worst. All right, fantastic. So now, let us find the slope. Okay, if you've forgotten that a slope of a horizontal line is always the same, then let us plug in the points. Okay, here I have 1, 2, 3. So 5, comma 6. And then my other one, since it's a horizontal line, my y should be the same. So my x is negative 3. And I'm just going to count just to make sure. 1, 2, 3, 4, 5, 6. Yep, it is 6. Perfect. Okay, now we're going to plug it into our slope formula. 6 minus 6 over negative 3 minus 5. 6 minus 6, that's just 0 over negative 8. 0 divided by negative 8 is 0. So the slope of a horizontal line is always 0. Okay, if you have 0 in the numerator, that is okay. Okay, so now let us look at the blue line. I know I'm going to use this ordered pair, which was 5 comma 6. And now I have 5 comma negative 2. Notice the vertical lines have the same x coordinates. All right, let's plug it in. Negative 2 minus 6 over 5 minus 5. Negative 2 minus 6 is negative 8. 5 minus 5 is 0. Negative 8 divided by 0 is undefined. You will get an error message in your calculator. A vertical line has an undefined slope. Okay, so if you have 0 in the denominator, that is a no-go, okay, because you cannot divide by 0, undefined. So what that means is these are perpendicular slopes. They are reciprocal opposites. So where they intersect, they make a little right angle. We can put that notation in there. Sorry, it's a little sloppy. So the only one that, okay, so in perpendicular slopes, when I say reciprocal opposites, I mean like you change the sign and flip the number. If you look here, it didn't change the sign, it's still negative, but this is a special case because a zero slope and undefined slope are reciprocal opposites. These lines are perpendicular. And this is the only time that it happens where the numbers don't work out. Because what should happen is the product, meaning when you multiply two perpendicular slopes together, you should get -1. But I'm not going to get that here because of there's special cases. So 0 and undefined are always perpendicular to one another. So the notation for perpendicular lines is an upside down capital T, in case you forgot, like so. Because I do love notation. It saves me, this is so much easier than writing that. And I don't even know if I spelled it right. I didn't. What the heck? Let me spell it again. Because I was trying to write it and talk at the same time, and sometimes it's hard to do two things at once. So, perpendicular. All right, well, now it's better, but it's still not better because I should have just written the upside down capital T, but now we all know what that means, so I will be using that notation from now on. Let us move on. Okay, so we're going to talk about slopes of parallel lines. We already know we're looking to have the same slope. So, in the coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. So we're just going to plug into the slope formula. 2 minus 1 over 6 minus 6. 2 minus 1 is negative, oh my gosh, I'm so sorry. Why did I say that? It's just 1. 6 minus 6 is 0. We can't divide by 0, so this is undefined. And if any of you want to come up with a notation for undefined slopes, that would be awesome, because writing this word out is not so cool. But anyway, I'm going to keep going. Here we go. All right, next I have -2, 3, and 1, 3. Let's see if they are parallel. 3 minus 3 over 1 minus -2 minus a negative. Just make it addition. 3 minus 3 is 0. 1 plus 2 is 3. This is just 0. So, slopes of parallel lines. These are not parallel lines. They are, in fact, perpendicular. All right, so now we're going to look at this next example down here. It says, are lines J1 and J2 parallel? Remember, that's what that notation means. So first, let's find the slope of J1. I'll just put this one in purple. Oh, whoa, I did not mean to do that. What just happened? That'll be purple. So 2 minus 10 over -5 minus -1 is addition. 2 minus 10 is -8. -5 plus 1 is -4. -8 divided by -4 is +2. So this is the slope of +2. I'm going to put J2 in pink. 1 minus 9 in the numerator over -2 minus 2. 1 minus 9 gives me -8. -2 minus 2 is -4. And -8 divided by -4 is +2. Woohoo! Yeah, same slope. Parallel lines. So, yes, we will answer the question, yes, they are parallel because they have the same slope. That's fantastic. All right, let's talk about perpendicular lines. In the coordinate plane, two non-vertical lines are perpendicular if and only if their product of their slopes is -1. Remember, that works for every single perpendicular slope except for the 0 undefined, right? Because that's a vertical, one of those, the undefined slope is a vertical line. All right, so, oh boy, let's try to see if we can graph these lines in here. Hold on a second. So first, I'm going to make J in red. J is going to go kind of right there between those two. I guess you know what, I'll try to use my line tool. Sorry, guys. Come on, girl. Get it together. See, look at that. That actually, like, really looks nice, doesn't it? So line J is in red. So I'm just going to name this J. And make it capital J, whatever. And we got to use our 2 points. So we have, let's see, negative 2, 2. So this is for line J. And then the second point is 2, 0. All right, now we're going to draw our line K. And that goes like here. Wow. Well, to hit that second point, I missed the first one, but I'm just going to move it because, you know, technology is pretty cool. But anyway. See, sometimes even if you have technology, it's better to just calculate the slope using the slope formula because my line might not be straight. I don't know. So the ordered pairs for K are the same 2, 0. And then another point in space that is 5, 6. All right, when I find the slope, well, I'll do K now since I already got my blue pen up. So 6 minus 0 over 5 minus 2 is 6 over 3, which is 2. All right, ooh, it's parallel to the ones above, isn't it? Now let's just find the slope of J. 0 minus 2 over 2 minus negative 2, which is plus. So now I have negative 2 over 4, which is negative 1/2. Now, the rule says if we multiply them together, we should get a product, it should equal negative 1. So negative 1/2 times 2 is negative 2 over 2, which is negative 1. Hallelujah. So yes, J is perpendicular to K. Yes. Let me just write yes right here. Boom. Answered that. We are looking good. All right, so now we're going to do some more examples. Let us flip the page. Okay, ooh, this is too big, too big. Earlier it was too small, now it's too big. All right. Sorry about the bells, guys. That's what happens at the end of the day. We have 20 bells. All right, line K passes through these points, 0, 3 and 5, 2. So let's plot those points. 0, 3, boom. 5, 2, kaboom. All right, I'm going to graph the line now. So I'm going to try to use my fancy graphing tool. Very close, very close. Okay, maybe, it's close enough, close enough. All right, that's K. Now, here is something that people always seem to get messed up. Once you graph this line, right, we need to find out what the slope is. So what is the slope of K? So if I use my formula to find the slope of K, we just plug it in. 2 minus 3 over 5 minus 0. Well, 2 minus 3 is negative 1. 5 minus 0 is just 5. So the slope is negative 1/5. Now we're going to graph a line perpendicular to K. So that means we're going to take the slope, we're going to flip it upside down, and we're going to change the sign. So perpendicular to K, the slope is equal to positive 5. So we know this is our new slope. New slope. What we're going to do is we're going to make this happen, okay? How we graphed the line perpendicular to K was we found the slope of K. Now we're going to go to this point because it has to go through this point, 1, 2. So I'm going to change my color here. I guess I'll use orange. All right, and I'm going to plot the point at 1, 2. 1, 2 is right here. I know I have to go through this point, so this will be my starting point. I'm going to apply my new slope, 5. Remember, it's 5 over 1, right? So we go from this point, 1 comma 2, up 5, 1, 2, 3, 4, 5, and over 1. Boom, nailed it. Now we're going to graph the line. Yeah, that didn't work out exactly how I wanted it to, but you know. Oh boy, I could be here all day trying to get this thing on there. All right. We know it's perpendicular because we calculated the slope, so we can go ahead and put that right angle in there because where they intersect, they make a right angle. Oh, that was weird because I'm still in the line tool. Ooh. Anyway, that's how you do it, okay? So you will see a question like this on the test and possibly in your homework that you need to, this line passes through 2 points. Graph the 2 points or find the slope. Then take that slope and apply it to the situation. Graph a line that's perpendicular to the original first line that we graphed and passes through this 2 points. So this point is our starting point, and then we apply the slope. Let's try that again. Let's see what happens here. One more example. All right, now we're going to graph a line with the point 0, 4 that is parallel to the line through -2, 4 and -5, 1. So first off, let's determine what this line's all about. So we go to -2, 4. That's right here. Then -5, 1. There we go, right there. Now I'm going to get my fancy line tool out. And I'm going to try my best. Hey, I mean, you know, if I do say so myself, that was pretty righteous. Okay, so let's calculate the slope of this line that we just put together here, okay? So 1 minus 4 over -5 minus -2 is plus. 1 minus 4 is -3. -5 plus 2 is -3. -3 over -3 is +1. That is the slope of my blue line. I need to go through this point, 0, 4, that is parallel to my blue line. So I guess I'll pick purple. What the heck? 0, 4 is right here, kabushki. All right, my slope has to be the same because it's parallel. So this slope was 1. So we go up 1, right 1, or down 1 and left 1, right? Because the double negative is still positive. Now I can get my line tool and graph this beautiful line as best I can. I mean, that's pretty good, right? Okay, since we know they're parallel because we did all the math, we can go ahead and put our fancy little arrows on here to show that these lines are parallel to each other. All right, fantastic. And you know the deal, guys. If you have any questions, just hit me up on Schoology. I'm always here. I'm around like a donut. Here is your assignment for today. Yowza! Oh, please don't look at that. That's old news. You guys already did these IXLs. This was, and I actually eliminated one of them. But you are going to want to use graph paper, please. The Google Docs, you guys got to try to practice this because when you get your test, you're going to be really upset that you didn't have practice. But you know, you don't necessarily need graph paper, but you're going to need to graph it. So, you know, you can do a quick sketch really easy, right? We just make our 2 number lines, our vertical and horizontal axis, right? That's my y-axis. That's my x-axis. And then you can just number it. Like try to say, you know, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. Boom. I got a coordinate plane. It took me less than a minute. You can do it. I know it. I believe in you. All right. Have an awesome day. Bye.